Okay, let's get into the second part of the endocrine function unit. We're going to start off with steroid hormones. We have three major ones we're going to kind of talk about. So we have our estrogens, we have some androgens, and we have what we call 21 carbon steroid hormones, which kind of make up our adrenal corticosteroids and progesterones. All right, so starting off with estrogens. Estrogens kind of a broad term that we'll use. It's our primary female sex hormone. It's kind of the important overall, all the estrogens put together kind of help play a role with development and regulation of the female reproductive system, sex characteristics, things of that nature. It's produced in the ovaries. And we kind of have a few different forms of estrogens that we will monitor, and they all have different purposes in terms of where we'll see kind of the highest levels at different points in the life of a female. The first one we'll kind of touch on is estradiol, which we kind of look at as the main physiologically active estrogen. So this has a huge effect on female traits. There is also estrone, which is actually an intermediate metabolite, which means it's kind of a breakdown product of your estradiol, and it's kind of a principal precursor to urinary estrogen. So it's kind of it's in the name, intermediate metabolite. We can monitor estriol as well. It's kind of the main estrogen that's present in blood and urine during pregnancy. So depending on which stage of life you're in, you may have different needs for measuring each one. For example, estradiol will usually measure for evaluating menstrual and fertility problems. Estrone we'll kind of see more as the main circulating estrogen after menopause, and then obviously estriol might serve us more when we're actually trying to measure estrogen levels during pregnancy. So overall, major biological actions, I kind of talked about it. The reproductive process rely on estrogens, but also note that they will have an effect on metabolism. So depending on what your estrogen levels are, it could affect your body weight and composition. It affects lipid, protein, carbohydrate, and mineral metabolism. Typically, you will see like where males and females may differ in terms of fat deposition is sometimes tied to estrogen levels. So if you have higher estrogen levels like a female would, you might have slightly different fat placement and musculature. So let's move on here. So I kind of mentioned earlier, estriol we kind of use for measuring our high-risk pregnancies. So it's really important for determining whether or not a pregnancy is going to plan. That could be anything from diabetic pregnancies, if we're looking at any sort of intrauterine growth retardation going on, preeclampsia, Down syndrome, etc. So that's where estriol can kind of tie into here. We want to kind of measure our estriol levels if you're going into a doctor to have this done and checked. You'll want to try and draw it at the same time each day because it does kind of go up and down. If you remember, our hormones have a way of having a certain biological schedule, so to speak. So kind of going forth with the monitoring our fetal placental function, a single level really doesn't do us any good. It's one of those measurements where we have to kind of look at it over time to get an idea of whether or not there's going to be issues with the pregnancy. And so what we see is if we have persistently low levels, there could be a problem. if we have increasing values, then that's saying that, okay, things are looking good. If we have issues where the values may be high early, but then they just don't go up, or they actually start to fall a little bit, then that also could indicate a problem with the pregnancy. And so moving forth here, we can also evaluate estrogens for looking at ovarian function. So this gives us an idea if there's going to be issues with ovulation, or if you are having difficulties with trying to conceive. We can look at different estradiol levels to kind of get an idea of what's going on. We can also measure our urinary estrogens. We can look at our total estrogen, and we can also look at single estrogens. So total being all of your estrogens, estradiol, estrone, estriol, or we can look at individual ones if we need to. All right, so the next thing we're going to talk about real quick is androgens. So with androgens, these differ from estrogens in terms of structure. Estrogens were 18 carbon steroid hormones. Androgens are 19 carbon steroid hormones, and these kind of represent more of the male sex hormones, particularly testosterone, although females do have androgens present. They have roughly 2/3 as much and considerably less of the testosterone. But we also talk about androsterone, epiandrosterone, and DHEA as well. These three right here, they are kind of weaker acting androgens. So they just don't have as strong of a biological function as, say, testosterone does. All right, let's see here. So speaking of testosterone, we kind of just generally call it the true male sex hormone. It's kind of what allows for males to have the sex characteristics that we do. Our growth and development of reproductive system is strongly influenced by testosterone, and it also is what triggers puberty. The other androgens can be they're metabolites, so they aren't really, like I said, they're the weaker acting ones. What's really important about testosterone is the fact that it does give, again, males the characteristics that we see in terms of like genital development, beard growth, muscle, sex drive, although with testosterone, it does also have an influence on the female sex drive, even with the lower levels that we see. Where we kind of see testosterone being important for women is it actually acts as a primary precursor of estrogen. So testosterone basically becomes estrogen in women. With the amount of testosterone present, we can see where a decrease in testosterone will kind of cause issues in terms of lacking beard growth or lacking muscle development in certain areas, or if we have a lack of sex drive, you might suspect low testosterone levels. Whereas in females, if we were to see an increase in testosterone, you would start to see more male-like pattern of hair growth, such as growing kind of like excessive facial hair, things of that nature. So our clinical significance, with males, we can see a decrease in testosterone when we have the condition of hypogonadism taking place. And again, with women, if we have overproduction or oversecretion, you get the condition known as hirsutism, which is basically the excessive facial hair, things like that. All right, so we're just going to move on here. The next thing we're going to talk about is our C21 steroids. So these have 21 carbons. The first one is progesterone. And progesterone is kind of viewed as a female sex hormone that we can use to help with alongside of like estrogen levels to kind of help us determining any sort of fertility issues or problems in general with conceiving pregnancy here. Progesterone as a steroid, it kind of just helps with the regulating your menstrual cycle, and then with pregnancy it kind of prepares the uterus for implantation and maintains the pregnancy. So progesterone is something that we will monitor throughout the course of pregnancy, and it can also give us an idea of what's going on. And so with progesterone, we have multiple metabolites. You can read through those. You can try to pronounce them. So we have pregnanidione, pregnanolone, and pregnanidiol. Sound very similar to the estrogen metabolites, just with pregnant in front of it. It's really our single best test for detecting infertility in females. So we were looking at estrogens for fertility issues, but we kind of have to look at estrogens and progesterone, if not progesterone, at least by itself. It also is helpful for tracking ovulation and pregnancy. So if we have issues with conceiving or anything of that, you can see where your progesterone levels are day by day, and it can help you determine if there's a particular day where ovulation's at its highest that gives you the best chance of conceiving. Okay, next one we have with our C21 steroids are the adrenal corticosteroids. So these are the ones that we'll kind of go over real quick because it kind of covers a good number here, and this is where we'll start talking maybe about a couple more disease states that are going to be of importance to everyone, testing-wise. So C21 steroids formed in the adrenal cortex, and their metabolites, we call them adrenal corticosteroids. Our main three that we'll talk about are cortisol, corticosterone, and aldosterone. And they kind of get broken up again into kind of two groups. So we have glucocorticoids and we have mineralocorticoids. With glucocorticoids, as you can see, it's involved lipid, glucose, protein metabolism. So these are the steroids that will help us with our basic metabolism day to day, keeping our cells alive, whereas our mineralocorticoids, as it's kind of implied in the name, helps us with regulating salt, water, potassium metabolism. So it's making sure that we're keeping the right amount of fluids in our body and not letting too much go and dropping your blood pressure, or if you hold on to too much, then our blood pressure goes up. And we've talked about one particular mineralocorticoid before, which would be aldosterone. All right, so first one we'll talk about is cortisol. Cortisol is a glucocorticosteroid. So we'll write that there. Cortical steroid. And we sometimes call it the stress hormone because there are a lot of conditions where stress will trigger increases in cortisol. Oops, almost got that wrong there. So it's kind of our stress hormone. So cortisol is synthesized by cholesterol, and it is controlled by that ACTH. We kind of talked about that earlier, from the anterior pituitary. So when ACTH is released and it acts on the adrenal cortex, we will have an increase in cortisol level. And so cortisol exhibits diurnal variation. So this one is one of those steroids that will vary based on the time of day. So what you'll see is you'll have the earliest level or the highest levels early. So we'll get a short little rise after midnight, and then we'll have a big peak in the early morning. So cortisol, when you're like needing to wake up, that is the hormone that helps wake you up. What we'll see is there's a gradual decline over time, and then we'll get really low levels, ideally between 8 and 4. So your lowest levels, even though we have an increase after midnight, will still be kind of up until that morning period. So when we are looking for cortisol levels and we want to monitor any sort of issues with cortisol, you'll typically see 8 a.m. and 4 p.m. measurements. Although I have worked in a processing department before where I've seen a lot of tests where the cortisol levels will be monitored maybe 4 to 5 times a day, and we'll get midnight and 4 a.m., 8 a.m., noon, and like 5 p.m., something like that. What we see in issues with cortisol levels not kind of matching what it should be, we have Cushing's disease and Addison's disease, where that diurnal variation just kind of disappears. So let's go on here. All right, so in terms of measurement of cortisol, we'll actually kind of measure some of the metabolites, and the ones that we measure are in urine. So with cortisol, we will look at the 17-OHCS. It's decreased in adrenal insufficiency. So that adrenal insufficiency is also known as Addison's disease. It's basically where the adrenal gland is just kind of, it's gotten lazy. It's just not working the way it should in terms of pushing out enough of our corticosteroids. So we'll see a decrease in adrenal insufficiency, whereas in something called Cushing's syndrome, we will have an increase. And then the same with an adrenal carcinoma. So again, remember, tumors usually lead to increases of hormones. And then the other thing we can measure is our plasma cortisol levels. And usually these are measured in the AM. So there we go. All right. Moving on here. All right, so what happens when we don't have enough cortisol being produced? We go under a condition known as hypocortisolism. Kind of look at it as primary adrenal failure as your main cause. This is something called Addison's disease. So with Addison's disease, we'll have a decrease in aldosterone and cortisol. So remember that the adrenal gland gets kind of lazy, and so not only is it decreasing cortisol, it's decreasing some of our other ones. And what happens is as your cortisol levels decrease, your body will say, oh, heck, we need more. So we're going to try and create more by signaling the adrenal glands with more ACTH. So our cortisol levels are going down along with aldosterone. And then our body's like, okay, we have to do something about this. Let's pump up the ACTH to try and help trigger more aldosterone and more cortisol. And so what you see with people with Addison's disease is they may not get that cortisol released because the adrenal gland is kind of broken, but what we'll see is a huge increase in ACTH. So big ACTH, little cortisol, little aldosterone kind of points towards Addison's disease. The other way we can see a decrease in hypocortisolism or see a decrease in cortisol is if we have a pituitary issue where we are not producing enough ACTH. So as your body uses cortisol, so it's going down here, and then we need to kind of maintain a normal level. Your body will try to increase ACTH, but with a pituitary ACTH deficiency, we also have ACTH being decreased. which ultimately leads to decreased cortisol and then decreased 17-KGS and 17-OHCS, which those are metabolites of cortisol. Pituitary ACTH deficiency is usually known as secondary adrenal insufficiency. So, secondary adrenal insufficiency. So just remember, if we're seeing that decreased ACTH and decreased cortisol, it's pituitary related. If we have a decrease in cortisol but an increase in ACTH, then it's definitely pointing to adrenal failure. Okay, so what happens when you have too much cortisol? You have too much of that stress hormone. This is something we call hypercortisolism. Usually with hypercortisolism, we see things like obesity or some sort of hypersensitivity. So I didn't gloss this over on the last slide, but typically increased cortisol leads to increased fat deposition. Whereas a decrease in cortisol can actually lead to anorexia. You might have excessive vomiting, weakness, and mental confusion. So people who have low cortisol levels, they have a hard time maintaining weight. People who have increased cortisol levels, they may be more on the obese side of things. So with hypercortisolism, we kind of attribute to something called Cushing's syndrome. And so Cushing's syndrome is basically overproduction of cortisol. There's some sort of either cortisol secreting adrenal tumor, or there's something called an autonomous adrenal secretion where it's just kind of going on its own there. So with that, we can see an increase in your blood pressure, muscle wasting, hyperglycemia. So we'll have that increased cortisol where we're basically not performing metabolic functions properly, and that's what kind of helps lead to that increased fat deposition, because if you think back to that diabetes unit, increased blood sugar is usually associated with bigger waistline, that kind of thing. So with hypercortisolism, primarily we're going to just talk about Cushing's disease. So just know that Cushing's and Addison's, they are kind of opposite of each other. Addison's is a decrease, Cushing's is an increase. All right, so moving on. So we talked about Cushing's syndrome. Cushing's disease is actually just a little bit different. This is a hypersecretion of glucocorticoids caused by increased ACTH by a pituitary adenoma. So Cushing's syndrome is more of an issue with the adrenal gland itself, where there's a tumor on the adrenal gland. The issue with Cushing's disease now is the pituitary gland. So the pituitary has a tumor on it, which, again, tumor increases hormone production, means we're going to have an increased level of ACTH, and as ACTH is increased, like so, leads to increased cortisol, and it leads to our increased amounts of 17-KGS and 17-OHCS, which are metabolites of cortisol. So just remember that Cushing's syndrome is adrenal gland related. Cushing's disease is pituitary gland related. And we can test for Cushing's disease with a dexamethasone suppression test, which I'll talk about here in just a second. Okay. I'm not going to go super in-depth over aldosterone because I feel like we've talked about that quite a bit. Just remember, I mentioned earlier that this one is a mineral corticosteroid, so might want to know that. And then just quickly maintain salt and water balance. If we have too much, we keep too much salt, we lose too much sodium, you get high blood pressure. Aldosteronism is the condition where we have too much. It's either adrenal related because the adrenal gland has a tumor that increases aldosterone output, or some sort of secondary aldosteronism where we have something outside of the adrenal gland being the cause. The one big change I'm going to make here, I think it's wrong on our notes as well, is that renin is actually increased with secondary aldosteronism. I'm going to just quickly also go over some of these metabolites. You heard me mention before 17-OHCS. This is a metabolite of cortisol, and it kind of gives us a good 80% representation of your C21 excreted compounds. So when we're looking for metabolites of our C21s, 17-OHCS is one we'll measure typically in urine. 17-KGS is very similar, but it is a 17-OHCS that's been converted over to a keto steroid, so that's where the K comes in. Again, this is also a metabolite mostly of our cortisol, so typically we'll do measurements of both 17-OHCS and 17-KGS as giving us a picture of our cortisol levels. And again, this also is usually measured in urine. (17-KS) is a little bit different. This one is a good measure of adrenal cortex function as well as androgen activity levels. But it's not going to measure all androgens. Specifically speaking, testosterone is not measured with 17-KS. So just remember, if we're talking about androgen activity, not including testosterone. All right. Moving on here. When it comes to the lab side of things, urinary 17-KS, OHCS, KGS, again, urine samples, and we want 24 hours ideally. So these are going to be one of those tests where we'll have the patient record for that 24-hour period, and we have to make sure that it's kept refrigerated. Something to keep in mind with the testing for 24-hour samples, specifically for these metabolites, is we want to discontinue medications if you can. And if the patient's taking aspirin and barbiturates, those are okay, but other medications could interfere with the excretion or output of those metabolites. And here we go. And so there's a couple of different reactions that we can look at from the chemistry side of things. The two we'll talk about, but we're not going to really go into super detail, is there's a Zimmerman reaction for 17-KGS, and then there's one called Porter-Silber. Two different types of reactions, and they can help us with measuring different precursors. And with the Porter-Silber reaction, it's just another type of reaction. It's an enzymatic reaction that takes place. It measures a couple of similar ones, similar analytes as our previous Zimmerman reaction, including cortisol and cortisone, deoxycortisol. And this one actually is really measuring 17-KGS with a very specific kind of configuration. All right. Now we're going to get into the fun stuff here in terms of what these results mean. So with evaluating our adrenal cortical function, we can do tests on serum and plasma. We talked about doing plasma cortisol, ACTH. We can measure aldosterone. And then the other one I talked about was the dexamethasone suppression test. So that's the one I'm actually going to kind of spend just a little bit of time with this to kind of give you an idea of what's going on. So with the dexamethasone suppression test, we actually can have 2 different doses given to a patient, and that can give us an idea of what kind of disorder that we are dealing with. So with a low-dosed test, so let's do this. So low-dose DEXA. Low dose can tell us a couple of things potentially. So if we have a low dose of dexamethasone injected into the patient and we measure their cortisol levels the next day, if we have low cortisol, that is a good thing. That's normal. Because if we inject low-dose dexamethasone, it suppresses ACTH, and if we're suppressing ACTH, then we should be seeing a decrease in cortisol levels. However, if we have normal or even high cortisol, that is not normal. Because if we're suppressing ACTH and we're still making cortisol or enough to make it normal or even high, this kind of points us in the direction of Cushing's syndrome. No, let's erase that. And remember, Cushing's syndrome, I don't know why I put a dot there. Cushing's syndrome is directly related to the adrenal gland. And then the other dexamethasone test that we can do is a high dose dexamethasone. So let's do that right there, high dose DEXA. So now we're going to put even more dexamethasone, and it's going to give us an idea of what our ACTH levels are doing and how that's affecting our cortisol levels. So if we do a high dose of dexamethasone and we have low cortisol, this gives us an idea that we have Cushing's disease. And what's happening is that high dose of dexamethasone should be suppressing the pituitary from releasing ACTH. And if it's not suppressing the pituitary like it should, since we're giving such a high dose, it's basically saying that something is causing the pituitary to make its own ACTH outside of its normal functions, typically speaking, a tumor. And that means that we're probably dealing with Cushing's disease here. If we end up having normal or even high cortisol levels, then we actually want to measure how much ACTH is in the blood. Depending on whether or not there's high or low ACTH, it could point towards some other issue with the adrenal glands. So that's kind of, again, dependent on ACTH high or low. Okay. Last thing I'm going to cover in this video is the adrenal medullary hormones. So we just got done spending some time on the adrenal cortex. We're going to talk about the adrenal medullary. These hormones are typically called catecholamines. With catecholamines, they disappear fast. So these are the ones I kind of mentioned in a prior lecture, that the circulating life of hormones can kind of vary from minutes to days. These would be our minutes. So we're talking about things like epinephrine, norepinephrine, and dopamine. These are the ones that kind of get your heart going sometimes. In the case of like epinephrine or dopamine, a sudden burst of it might make you feel good for a short period of time. And these can be very important to monitor, as they tell us if the adrenal gland on the medullary side is correctly functioning. They typically act as either like neurotransmitters, like in the case of dopamine, but then, like I said, the others can act as just kind of quick little bursts of energy to kind of pump up the metabolism for a brief period of time. And so with norepinephrine and epinephrine, they eventually will get secreted in urine, or they get metabolized to normetanephrine or metanephrine respectively. And then they can get further metabolized to something called VMA, which is 3-methyl-4-hydroxymandelic acid. And then with dopamine, that actually gets metabolized to HVA or homovanillic acid. And these are what we would usually measure, again, in urine to determine if we have high or low levels. And so where it really comes into play with seeing different levels in our urine, an increase tells us that there may be the chances of something called a pheochromocytoma, which is basically another word for a tumor of the adrenal medulla or sympathetic ganglia. Basically what it does is that tumor leads to, surprise, increased quantities of the hormone in question. Typically we're talking about a patient complaining about like high heart rate that doesn't settle down, or you get headaches, tightening of chest, sweating, all the things you would imagine with like anxiety or just constant, you're on the go, you're just completely wired. But the good thing is with a pheochromocytoma is they can be surgically removed. So typically speaking, you go in, cut off the tumor, and we'll start to see the levels of catecholamines, epinephrine, etc. Those go down. We can measure plasma catecholamines as our indicator of whether or not there's too much. But again, remember, they don't last very long, so you kind of have to catch it in the moment. Otherwise, urinary metanephrines usually will do the job in terms of detecting the tumor, as the metabolites will last a little bit longer in those urine samples. Typically speaking, those are also done with 24-hour urines as well. Couple of other causes of increased catecholamine levels in children. There's something called neuroblastomas that kind of goes along with the ganglia side of things when I mentioned earlier about ganglion tissue being involved. Ganglioneuroma, hypertension can cause that increase because, again, hypertension associated with aldosterone associated with your adrenal glands. Plasma catecholamine, again, best indicator for those types of issues.